Okay, so this is assignment 3 for SLHS1302. So for part 1, you have to define a few concepts. So this is kind of like assignment 2 and 1. So the first concept is time series data, the second is time plot, and the third is bin size. You can find these definitions in your chapter 3 notes under the unit 1 section. So if you go to the Canvas site, you select unit 1, and then you go to chapter 3. You should be able to find it at some point in these notes. So actually right here on the second and third slides. All right, and then you also have the question, describe the basic procedure for using R in data analysis in your own words. So we're looking for you to have 4 steps here. And so if you think about what we usually do when we're analyzing data in R, we want to first load and read in data. And then the second step we usually do is we manipulate the data. We generate variables for our analysis. And then the third step we usually do is we analyze the data with descriptive stats. And you can also generate graphical results. And then lastly, we save our history. All right, so for part 2, we have to create the directory like normal. So if you're still having trouble with creating your directory because you cannot figure out your username, use this code line right here to do so. So if we copy that and paste it into R, and then run that, it will give us our username at the bottom of the screen in the console. So you'll see that it's my name in the quotations. So then, I would replace those X's with that username. And then remember to use the correct code lines for whether or not you are a Windows user or a Mac user. So as a Mac user, I will copy these code lines, and then I'll put them in R, and I'll replace the X's with my username. All right, and then I would want to run those lines. And then the reason I'm getting the warning message is because I've already created this folder previously. And then if I wanted to check to see if the current working directory is for assignment 3, I would do get working directory. I'd run that code line, and then it'll show me down here that I'm in the assignment 3 directory. All right. So now that you've set up your directory, you're gonna now generate a bar plot from chapter 1. So you can find this figure in chapter 1 of your textbook, and it'll be on page 27. So if we go to page 27, we can take a look at what this image will look like. So this is a figure, the figure that we're trying to copy. And then this is the data or the table with the data that we'll be using to create this figure. So we see here that we have a code line for MHR. So we'll copy that line into R and we'll run it. And so then we'll see MHR over here in our global environment. And then now we want to assign names to each of the values. So F will go with 527, PH will go with 26, and GH will go with 10. So we'll copy that, put it into R, and run that. And so now those values have been assigned names. Okay, so down here we now want to put the values for CPWD in. So if we go back to the textbook, we can see that the values we're looking at here are 894, 38, and 16. So we'll replace this highlighted area with 894, 38, 16. And then if you look up here, we see that we did names, parentheses, MHR. So down here, what we're going to want to do is names parentheses, CPWD. And now you can run these code lines. So this first code line that we're running it's a vector that we are giving the name CPWD. The second code line will assign these values with different names. So we'll run that. All right, so over here we see that the CPWD and the MHR variables are up in our global environment. All right, so now we want to create two bar plots side by side. So we see here it says that we want to have one row and two columns. So we'll replace this highlighted region with a 1, 2. So 1 for the one row and 2 for the two columns. So this will set up our studio so that we can have two side by side plots. So we'll run that. Go back to the Word document. All right, so now we see these code lines for the two different bar plots that we're wanting to create. The first one is for MHR, the second one is for CPWD. Both of them are looking at the spellings of the consonant sound F. So we'll take these two code lines, copy them, and then paste them into R. And so then we will run those. All right. And so over here in the plots, we're seeing those two different plots side by side. So we have the MHR, the CPWD. On the x-axis, we're looking at the spellings of the consonant sound F. The y-axis has number of tokens for each type. So the spellings of the consonant sound F are F, PH, and GH. And then the number of tokens for each type are just how many have been found for each category or type or spelling. Okay, so back to the Word document. So now the next code lines are going to save our image that we just created. So we'll run those. All right, and now you'll see on the Word document it wants to insert your figure. So we can export that to our desktop if that is your chosen method. Otherwise, you can save it to your directory, among other things. All right. So then we'll drag this into our Word document. All right, and so then if you wanted to, you could compare this graph that you've generated with the one from the textbook, and we can see that they're pretty similar, or very similar, as was our goal. Okay. All right, so now for step 2, we're going to generate a histogram from chapter 2. We can find this histogram on page 45. So let's take a look at the textbook. We'll go to page 45. And then so the image we're going to be trying to recreate is this top graph right here. So it's a histogram of word lengths in number of letters in the Hoosier Mental Lexicon, or as you may know it, the HML. So what it's looking at is the different lengths of words that occur in this lexicon, and then the number of words of that length. So the frequency. So how often does, a letter with 3 or a word with 3 letters occur? How often does a word with 6 letters occur? And so on. So that is the image we're trying to recreate here. So first we'll have to get the data set from this source. So you want to copy this code line, go into R, and run it. All right. And so then you'll see it pop up over here as MHL in our global environment. And then that MHL just stands for the, as we saw in the textbook reading, hold on, if we can get it back up here. So on page 45 for the Hoosier Mental Lexicon. All right, so we did copy that. So now we will want to take some of the information from this data set and assign it to the name n.ch.html. So we'll run that line, and so we'll see it over here in our global environment, the n.ch.html. And what the n.ch stands for is just number of characters. All right. And so now if you wanted to see the first six values of this variable, we would run head parentheses n.ch.html. So we'll copy this code line, go into R, we'll run it. And so then we see the first six values down here in the console. So 1, 8, 5, 6, 5, 7. All right, and so now if we wanted to create a table from it, we would run this code line. So we'll do that. Copy it into R, paste and run. So now we see over here that table for NCH has been created. We can see it in the global environment. All right, and then if we wanted to see what the content of this table looked like, we would just type in t.nch, run that, and it'll show us what's in this table. All right, so now if we wanted to create a histogram for that, we would first want to do this code line right here. This will set it up so that we just have one row and one column in the plot section so that there will only be one figure. So we'll run that, so that's set up. And then we will run our code line for the histogram. And so then we'll run that. And then we'll see it pop up here over in the plot section. So what it is a histogram for word length in the HML word list. On the bottom we have number of characters, and then over here we have frequency. So if we wanted, we can make this bigger, and then we'll see all of the values down here, because when it was smaller we were missing a few values down here, but when we increase the size of the plot section, we're able to see more information on the plot. All right. And so then if you run this code line to save it to your directory, all right, so run those two lines. All right, and then if you look at your assignment document, it's showing you that it wants you to insert figure 2.2. So we'll go to our studio, and you can export it in whatever way you prefer. And so I'll save that. Just going to make this a little bit smaller again. All right, and then we will paste that into our assignment document. And so this is the image that you should have for this figure. And so then if we go back to the reading, we'll see that we've created a very similar figure to what is in the reading. All right. So now we can move on to the next part. So in this step, we're going to generate a time plot from chapter 3. So the figures that we're recreating are these two right here. And so then these two figures look at time plots for the number of vowel letters in the words chocolate and government in the text cited in the earliest of the Oxford English Dictionary definitions of these two words. So we can see if we just look at this quickly that in 1600, chocolate had 4 vowels, whereas in 1680, it went down to 3. And then we can see a similar thing with government. So around between 1450 and 1500, there were 4 vowels in government. Whereas if we go to 1700, we can see that there were only about 3. All right, so first what we will need to do is read in both of the data sets. So the first one will be for chocolate. And so we will copy that code line and paste it into R. So we'll run that, and then you should see the chocolate or CHOC in the global environment. And then we want to run the code line for government so that we can get the data set for government in. We'll run that, and then we'll see that as GOV or gov in the global environment. All right, so now we want to create a plot with 2 rows and 1 column. So it's a little bit different than what we're seeing here. So instead of side by side, we'll have one over the other. And you'll see what I mean in just a second. So we'll want to run this code line right here so that we can get the 2 rows and 1 column. Run that, so that'll set up our plot for us. Okay, and then we'll go back to the Word document, and then we'll grab the 2 code lines for the 2 different plots. So we have a plot for chocolate and a plot for government. So copy those, paste them into our studio, and then run them. And so then here we see chocolate and government, and so we have the 2 rows and the 1 column. And just to go over the code lines a little bit, we're seeing that with the X lim, it's having it start at the year 1460 and bringing it to about 710 or 1710. And then we're also seeing a similar thing with the Y lim, where it's starting at about 1.5 and going to 5.5 on the axes. All right, and so then we'll copy these code lines to save to our directory. So we run that, we're good. Okay, and then if you go to the assignment document, it sees that, or you can see that it wants you to insert your line graph here. So we'll go to RStudio, and then once again, export however you prefer. And then paste it into your assignment. And so this is what you should have for this figure. All right, so for part 3, we are going to look at a data set that is already within R. So first we're going to need to activate the 2 libraries, stats and graphics. So we'll just copy these 2 code lines and paste them into R and then run them. Okay. And then so now if we want to look at the data set cars and we want to know what is in this data set, we would do the code line help parentheses cars. And so in RStudio, we'll see that it'll give us a description of what the data set cars is. So if you look over here in the help window, we're seeing that the data set labeled cars is about the speed and stopping distances of cars. So the description given here is that the data given, or that the data give the speed of cars and the distances taken to stop. And it's important to note that the data were recorded in the 1920s. So the name that it uses for this data set is cars, and we can see that it has 50 observations and 2 variables. All right, so if we wanted to examine what is in this data set, we would run the code line cars, as you can see here. So you want to copy that, paste it into R, and then run. And so you'll see here in the console is the values within this data set. So we can see that there are 2 variables. We have speed and we have distance. And there are 50 observations of each. So now if you go over here, you have some questions that you need to answer. So it says, observe the data contained in the 2 columns, speed and distance, or DIST, which stands for distance, and answer the following 4 questions. First question is, are the data in column speed continuous or discrete? So let us take a look at the values in speed. So we see that we have a number of whole numbers, and if we look over here in the help window, we can see that the speed has been put in miles per hour, So although we do have whole numbers, we have to keep in mind that the speed of a car could be 4.5, or it could be 4, it could be 7.5 or 7. It really just depends. So in that case, we would say that the data in column speed are continuous. All right. So for question 2, it says what scale of measurement applies to data in column speed? So there are 4 scales of measurement: nominal, ordinal, interval, and ratio. So the scale that we would use for speed, or miles per hour, would be ratio. And you can find this in your Unit 1 notes. All right, so the third question is asking us about the column distance. So it says, are the data in column distance continuous or discrete? So if we look in the help area, we can see that distance is in feet. The values they give us are all whole numbers, such as 2, 10, 4, so on. But keep in mind that, you can have 2.5 feet, 10.5, etc. So once again, we're dealing with continuous data. All right, and then for number 4, it's asking what scale of measurement applies to data in column distance. So just as we were dealing with the speed column, the distance one is also a ratio scale. All right, so now we are going to create a plot of these two variables to see the relationship between speed and distance. So we'll copy this first line, and what this line will do is set up the plot so that we have one row and one column. And then we will run the code line for the plot. Okay, that didn't work. Let's try that again. All right, and we'll run that. And so here we see our plot. So we have speed on the x-axis, stopping distance on the y. And so you can kind of see that the data points are sort of making their way up. So as speed increases, so does stopping distance. And the way we can further verify this relationship is by doing a trend line over the scatter plot. So these two code lines will impose a trend line over the plot, and we can see how this relationship really is. So you see, here's the trend line, that red line. And so, as I said, as speed increases, it appears as though stopping distance is increasing as well. And so then, in your assignment document, it is showing that you should insert your scatter plot with the trend line. So export your image. And then place it in your document. And so then you have this last question to answer. It says, from the graph, we know that there is a trend that when speed increases, stopping distance increases. Thus, the faster a car goes, the blank distance is needed to stop the car. So what you would want to then say here is that, thus, the faster the car goes, the longer, greater distances needed to stop the car. So you can either use the word longer or greater. They both mean the same thing. All right, and then the last thing you'll want to do is save your history. So we'll go into R, copy and paste this line, run it, and your history has been saved. All right, another way to save your script is to also just click the little save button in the corner and then title the script whatever you want. So you could title it Assignment 3 if you wanted, and it'll save to your directory if that's where you are choosing to save it. All right, so just to go through the assignment quickly one last time, you have these concepts that you want to fill in. You can find them in the Chapter 3 notes under Unit 1. You have this second question that you'll want to answer. You'll have this figure that you'll want to put in. And then also remember, you had these code lines that you had to finish yourself. So that one, this one, and this one. And then you had another figure, the histogram, a third figure, You had to answer the 4 questions here. Misspelled that. And then you had your final figure, as well as that one last question at the bottom. And then that should be it for this assignment.